We'll see. Yeah. So, another one. So I'll start with a theoretical question. Let's say we have a function. I hope you can see my screen. Let me zoom this one level, 2 level perhaps. Do something and equals to. Let's say this is doing some stuff, right? Let's call it not implemented. What can we say about this function? Can anyone make any comment? Let's say we don't see the implementation. There's some sort of implementation here. Implementation here.
Say, that name is misleading. So it doesn't really do anything.
Okay. Why do you think so?
Well, it just fails immediately. I suppose that's something.
But if I do it like that. Well, okay, they didn't. Let's set aside the name because it's an arbitrary name. What else we can say?
It fails all the time.
Okay, let's just see, because I just want to make it satisfactory. And there's some implementation. Let's say it's going to fail. It's not failing, right?
We know that it has to have some side effect or does nothing, since it doesn't have a return type.
Yeah, that's actually the thing I wanted to hear. Why do you think so?
The unit return type, right?
Okay. So if I were to say you that this function does not have side effects, what would you think with the statement?
Well,
it just does nothing, right?
Okay, so that can't be true, right? I mean, unless I make this. I mean, unless my intention is to create a pointless function, that can't be true. That I said that this function doesn't have any side effects, which is impossible, right? Then there's no point in writing this function in the first place. The intention is that it's taking a unit and returning a unit. That means that it has to do something as a side effect. So that's for sure. But again, as a good convention, if I were to design such a function, personally, what I would do is I would just mark it as just as async. And the reason being is it not because necessarily async. Well, async implies that you're calling another async code, such as another function, but I prefer it to be a surrogate that denotes this thing is just an effectful function. So we agree on that. So this thing can't be side effect. So if by the same logic, if I give you this kind of function, what would you think? Then let's call the output to be it as well. What would you think?
It might do something, but I'd hope it wouldn't if it were following good practice that, performs some kind of business logic and then returns an integer.
Yes, perfect. That's a perfect answer. So it actually F# doesn't allow us to restrict it to do anything against this, but essentially, if I were writing this function, I would say, at least let's say, if I see this code with the people who I know, I would assume there is no side effect with this function. And the reason being is if it had any side effect, then it would have been marked with async by convention, not because F# forces me. So once we agree on that, then actually you start to see that there are some pure functions and the non-pure functions. And there are some effectful functions and the non-effective functions. Actually, this discrepancy, this kind of separation goes quite fast, such as there was a language called Eiffel. Has anyone heard of it?
Sorry, what was the name of it? Sorry, what was the name of it?
Eiffel.
I've heard of the name, but that's it.
That's a very old language. And I'll show you a page first so you can see that's this thing. And it's a language that came up with this I think perhaps one of the first, I'm not entirely sure historically, this design by contract thing, right? So you say, well, whenever you call a function, you actually require or ensure, right, things. So then I'd like to ask you, what do you think about the correlation between having these kind of contracts and being effectful? What do you think? Is there any correlation? Can you see? In particular, invariants, for example. But let's say if I have a pure function, do you think I would need invariants?
Well, you might. I mean, if these are like sort of the equivalent of compile time asserts or something like that, then yes, you still may want that.
Why would I?
Well, when you're using the function, you may want to enforce that your function is being used in the correct context, perhaps. I mean, that would be if it was something like
that's valid, actually, what you say. But actually, that's what you say is more like an assertion. By definition, invariant is some condition you want it to hold indefinitely. What you say is I would say it's correct. I mean, you can argue that, well, I would like one of my queries to be only executed under some certain conditions, but what happens if that condition doesn't hold? And how do you communicate? How would you communicate that this thing should not happen? So the idea is this. In general, we can say that if you have a non-effectful function, a pure function, then these invariants and even perhaps the design by contract kind of thing starts to seize its point. Because in particular for the invariant, because your function is not going to change anything, apparently. And then if it's not going to change anything, whatever your invariants you had, they will be they will still be valid, most definitely, because your code isn't going to change. So the thing is, this guy, his name was, I forgot. Anyway, well, he was very famous actually. Came up with the idea that the CQS idea, the command and query separation idea, where he observed where some of the functions are effectful, or let's just say changing things, and some of the functions are just for query based. And then he argued that let's make a separation for our code. Let's just this in method wise, we can argue that we can mark some of the methods as non-effectful and then pure, and they definitely, from his standpoint of view, which I agree, don't need this kind of design by contract. Whereas the ones that are effectful would most definitely try to keep some sort of invariant and preconditions. So that's the essence of CQS. Can you think of an application or something similar of CQS in HTTP world? Could anyone think anything?
Yeah. I think let's say if you want to change any type of state, we might think of it as a effectful, right? Because it changes some of the state.
Yes.
And if we let's say if we are going to get some data from database using one of the endpoints, that endpoint will be effectless, I guess, because it just returns data and that's it.
Yes. So how do we utilize this? What is the corresponding concept in HTTP world? Let me give you hints.
Like the post or the patch verb would be effectful things like that, or put.
Yes, precisely,
Yeah.
precisely. So we have HTTP verbs, which is in the RESTful approach. We have get, post, patch, put, delete, right? And among them, get is known as the safe verb that is not meant to change things. And it communicates that intent. So it communicates the intent. And because of that, get is safe. When you, for example, you've written a public application, public web application, the crawlers like Google will invoke for all these get things, whatever they can do, whatever they link found in your application. And because get is safe, it should not cause anything in your application, even though the crawler would have scanned. If this separation didn't exist, then probably you would see some sort of maybe perhaps some dummy records just because the crawler just scanned your web application, right? So the concept is, why don't we apply the same concept to the programming? Why don't we have this kind of separation in the programming? So that's how this thing came out. So you think about you're coding something where your program consists of a lot of code. If you try to separate these portions, some of the portions are non-effectful on the query side, and some effectful side, the command side. If you can logically separate your program into these two logical divisions, then what do you get? What do you think is the benefit? So the benefit with the HTTP we get is the safety. What do you think the benefit would be for your code? Yes.
Sorry, the benefit, like, what is the benefit of using CQS, like, in general with your code?
Yes. I mean, let's say you decide to use it in your code. What would you get as a benefit?
I mean, if you decide you want to change your interpretation of the events that have occurred later on, I mean, or you want like a slightly different one, or you want multiple interpretations of that data to be sitting side by side with one another, it affords you a great deal of flexibility.
But I haven't spoken about the data yet.
I see.
Well,
I want to add one thing. Maybe it adds value. Like if we, in our system, if we have lots of reads, or heavy reads or heavy writes, we might it might be more flexible to adjust the the number of instances of the application. Let's say if you want to separate the concerns, like we want to build one system, but using two instances, one instance for the writes and one instance for the reads, and we might change the number of instances based on the demand. Like we can set up.
So you can say I can scale my application.
Yeah, exactly. Based on the demand.
I can scale my application because the read size I can multiply, because I can have hundreds of instances of my read side, which is absolutely true. But still, I have absolutely no objection to that. But let's say our application doesn't have any scalability issue. Does CQ has a place?
Yeah, I think where you're going with this is basically in the same way that you're talking about this whole thing about marking things effectful or not. Like with CQS, it's the same thing where you know that anything that's going to be happening, sort of like by separating your write side and your read side, you basically have, again, it's this partitioning of what is going to have sort of like the outside world side effect. And when you use a style like that, you're kind of marking like at what point the side effect happens of changing state within your system. And I don't know, I think that's where, that's like another property of the system.
Yeah, you're getting close. So my point is that in my perspective is that just just like get is a safe function, right? Safe method, set HTTP verb. You're actually you're actually reducing the attack surface of your application. But by attack surface, I'm not referring to the application security. I mean, while as a developer, you're writing code, right? And then some of the input, some of the user interaction, some of the input that's coming can cause some sort of bugs, some unwanted intention. And if you don't do CQS, let's think about the case where you don't do CQS, then the possibility that you're changing some of the state in your application is dispersed among all your functions. So by using CQS, you're grouping some of the things that change the state and grouping some of the functions that do not change the state. Essentially, what you're getting is that you're reducing the attack surface in terms of bug surface, let's call it. Well, that doesn't mean that query side can't have bugs. It can, but the thing is, even there is a bug in the query side, which can, of course, mislead the user, etc., it's not going to cause your application to have an invalid state. Do we agree on that?
Yeah.
So in that sense, the intent is to reduce the bug surface. That's the intent of it. In one sentence, at least my own interpretation. That would work just like the pure functions. So we, as F# developers, we know the benefit of having pure functions. It is doing the same thing, right? We can focus in a portion. Once that we can, while working with a pure function, we know that we can look at that portion of the code, and then we don't have to worry about what's going on the outside of the world. I mean, because it's not going to change state. So this is getting the same kind of benefit, not just functional level, but it's a little bit more architectural level. That's what I call as the benefit. Any agreements, disagreements, objections, questions? Because I'm trying to give the motivation, right? Rather than, at least from my perspective, other than that, if I just bluntly explain the pattern, then, right, without the benefit I'm getting, without explaining the benefit I'm seeing, then there isn't much point. Then you should question, why should I bother with this? It is to reduce the bug surface. Just you can have a set of functions, so you're separating your application rather than intermixed of querying, reading, writing, and this kind of things. Then the writing is dispersed everywhere. Then your bug surface, where potential changing your application, is dispersed entire application, and that's not something we want. But that's the primary reason. But the secondary reasons is that, well, you have the benefit of scalability and other things. That's just good to go. So that's all I'm going to talk about CQS itself, which will lead us to the CQRS part, which is a little more, one level more of that. So let's just talk some sort of drawing. I'm pretty sure you're most of you already familiar with the concept to a degree, or at least heard of it. But the idea is, well, if I can try to draw here, I hope I'll be successful. The idea is, well, you have your perhaps the presentation layer as I have awful handwriting, but just try this. It's called presentation layer, and you have the model typically. The idea is we can take this to one more level extent, not just a separation of functions here in terms of read and write kind of thing, but can we separate the model into two pieces, right? This is typically actually a little bit confused with if the data storage, which is actually aligned, should be separate in CQRS, and in the CQS case, the database is single. But I'm not perfectly aligned with this. So instead of that, can we have two different models, whereas there's a read model and write model? So read model, and write model. So what do you think about this? Why would I bother? So this is just let's say you have a classes that represents your model, and then you actually create two different set of things. These are for the querying side. You have a different set of classes, perhaps. At least the logic is different. And for the right side, you have a different model. Now, based on what I told so far, what would you think that what do you think the benefit of going through this extent?
I mean, basically all the things that have been mentioned in the past, or like that we just mentioned, for scalability and interpretation of data and separation of concerns to prevent invalid states and bugs, etc.
Okay, that's true. That's a little broad. I'd like to focus on. I mean, everything you say is absolutely correct, but I'd like to focus on the core part of it. Scalability is definitely a benefit, and I would say it protects your core data. So that's the intent. Protects this part. The reason is that think about you have developed an application, and then every time there is a change, let's say your boss asked a different report, right? Something that you didn't think before. Then you go to your database, you add a new column, you add, if you use an ORM like Entity Framework, you go to your core classes, you add a property there, right? And you redeploy and pray. As developers, what we don't like is change. So there's the onion architecture, if you remember, which was very popular. So there's the core part, the application layer, service layer, etc. The intent of the core, the onion layered application is the same. The most valuable part of your application is the core part, and the least, I mean, the last thing you want is to make changes here. Well, almost every business logic will land anyway, but as long as you don't change here, you will feel safer. If you don't have this kind of separation, every kind of querying intent will cause your core model to he will have to modify your core model if you don't have this kind of separation. That essence means a newer deployment for your core model and potentially new bugs, because every change you make is a bug. They can bring bugs. But if you do have this kind of separation, if you can separate your write model from reads model, then again you are reducing the bug surface. Whereas whatever bug you introduce here is not going to break your state. It can return wrong data, and this can cause an issue, yes, which can the user or the application can get false input based on what's read. That's true. However, it's not directly going to cause your application state to be corrupted just because you have a bug here. So that's the intent of it. That's the primary reason. But once you go with this, then suddenly other ideas came up, such as, well, actually, first of all, you have the scalability issues, right? I mean, not issues, benefit. And then you have a freedom to represent the data source here based on different tables, different data storage, and here, different tables and different data storage. And this brings us CQRS with event sourcing, which is another option, another flavor. So we are going step by step. At first, we covered CQS. Now we covered CQRS, which is representing the model level separation. And then we have the event sourcing. But none of these are compulsory. So you can pick a level as much as you want. And event sourcing flavor is actually very complementary, especially if you do the functional programming and event-driven architectures. but I mean, it is compatible. Doing CQRS, sorry, doing event sourcing without CQRS, it is possible, but I feel like it's challenging. So anyway, we'll talk about that as well. So I'd like to ask you probably heard this so many times. It's a very popular concept, right? Event sourcing. What do you think the benefit of event sourcing? And what is the disadvantage?
I mean, you get an immediate audit trail for anything that's happened in your system, typically. I mean, that's
true.
That's
but if I say let's just use logs for auditing,
well, then it comes to like what I mentioned earlier, which is it's very easy to correct a interpretation of your data, or either correct or just change it should you so desire. So if you're using if you have every change of what happened over time and you want your end state of how it's interpreted to be something different, I mean, you have that option available to you.
Okay. But could you rephrase it?
I mean, it's kind of hard for me to even imagine like using event sourcing not with CQRS, but yeah, just the benefit that like you can have different forms of projections of your event sourced data, so that because when you have event sourcing, like you're building up to some kind of like final read state. And so if you want either one, you want to change it because you realize you made a mistake, or two, you just want to have two simultaneous read states that, for different use cases. I mean, you have that option available to you.
Okay. Well, I need to a little bit wrap up. What you say is correct, but I need to a little bit more wrap up to this. Any other ideas? Why you heard this concept, event sourcing? Why do you think people mention this? There's one primary reason, and I like to talk about the primary reasons only for the time being, because this is the intent. Yardic's eventual consistency, scalability, and then read side projections. Yes, they're all there. There's one primary intent, which is, according to me, of course, you can have your own opinions. I'm not the authority here, but it's just declaring my opinions. Is not to lose any event in the system. In a sense, whatever I would like to record, like taking a note of everything happened in my system. When did this happen? And how did it happen? Who made it happen? It's like a transcription of my application. That's the primary intent. So essentially, it allows me, well, as much as I model my events, because modeling events is easier than the other kind of things. It's actually very human intuitive if you think about events. Well, what do you think? The benefit of recording everything then? So I said that event sourcing is primary reason exists for recording everything in my system. So the question is actually not difficult. Basically, if tomorrow someone asks you a question that you didn't think about it, I mean, let's think about there's a row and there's some record here, right? It's changing. There's I don't know. People vote for something, right? For example, and your vote count, like 1, 2, 3, 4, 5, 6, increasing. So if you just record this kind of thing, or just think about the stock amount, like there's a product and then there's a stock amount, like 50 items and 49 items and then 48 items, and you're just updating a record. This is the classical CRUD sense. And someone if asks you, what is the rate of the decrease of this product, right? How many we sold between these 2 dates, for example? With the regular crowd approach, if you just model your product with the stock amount, that information is lost, right? But instead, if you have a set of events, so event log that denotes like product sold, this kind of thing, or the event log, right? Then it is possible to query this event and replay this event log. Well, I messed up. Okay, I hope this is okay. With can I just scroll down? Yeah. I need to reload it. Let me just reload the page. So if I have this kind of event log, like product sold, then you have the opportunity to query what you like, how much product is sold, or something like that per rate. So that's actually the event sourcing is about not to lose any information. That's the point. Any info. And what you do is you typically create a projection engine, right? Which replaces this data. There's a projection engine here, and which basically scans these events, and then whatever database you use, a MongoDB, Cassandra, SQL Server, and other things, right? It will just create the regular record. So let's say you create this kind of things, and then later your boss asks you to have, or your customer asks you to have a different kind of report. Then all you have to do, write another projection engine, and then just scan these events once more, right? And then you can just create another table out of it. Then that's where you don't lose any data. Agree, disagree? Additions?
Oh, so this, like, you don't lose any of the data. That's assuming that you can answer the new question with the data that's already come in. Like the event is like the question the customer is asking you to report on, you already had that info, like the number of products sold, you have that. But if they're like, oh, what if there's some other attribute of the product that just wasn't in the right model, we would still have this doesn't help us here. Is that fair to say?
That's true. First of all,
Okay.
thinking of events are easy, but again, you can argue that, which is I would agree with you, let's say. So are your events rich enough to contain the enough data? Probably.
Okay.
Let's think about a product. But there are some sort of, for example, let's think about that you're using your logging user activity, right? User login, and perhaps you decided not to include the user's IP address in that event.
Yeah.
As an example to what you say, and yes, there's nothing you can do for that. Absolutely.
Okay.
I mean,
Gotcha.
But
that's fair. It's not it's not a gotcha. That's fair. I was just curious.
That's true. What you say is true. Of course, you have to think ahead, but it is still you realize this thing is missing, and then you came up with another kind of event login with IP, and then you can just recover. It's not a panacea, true. Not going to cover everything. That's especially if the data is coming from an external system. Perhaps for product, it is safer because product is something you have. So you probably know everything about the product, and then you don't need. But for example, something like an external data, and then like an IP address of the user, maybe you didn't decide to record it. That's some missing data, but it helps. So, anything else? Anyone want to add anything or objections or additions? Okay, so far so good. So that's obviously the other benefits is that when you have the event log, you can project this to data to different kind of data stores simultaneously. depending on your queries. And again, you have the scalability benefits, asynchronicity, because this is only write only, right? This can be sharded to different mediums. It's only append only data. So you can have a lot of different performance benefits. So depending on how you scale out. These are the second benefit. What about the drawbacks?
Complexity, potentially.
Yeah, that's true. I mean, compared to creating something transaction just writing, it's just you definitely need some sort of helper. Doing this manually, it's difficult. I would say that's definitely a good drawback. Probably number one drawback of this thing is just it's more complex. What else? What?
You have to deal with eventual consistency, which is probably fine, but still.
Yeah, that eventual consistency is a bit interesting concept. Which is true, right? Because we developers like that whenever we commit something, we want that to be finalized. So this is one, wow, I committed my transaction and now it's database's problem, not my problem anymore, which is a good safety net while developing. And now you're essentially losing it because just because you have written things to here, then you can end up with I mean, your projection tables aren't there. And worse than that, if you screw up something like that, if you miss an event in between, right? Then then I don't want to be in your shoes. This can go very bad and nasty way if these things go orphan or skip. There's a bug here. Then you can end up in a very ugly situation. I would say. But in terms of eventual consistency, now you have, because this commit doesn't guarantee this commit. It is usually forgivable because if you think about, you're looking at a web page, then I mean you're looking at a table, some sort of customer data. It's while you connect that web page, it's already a stale data. You know that, and it can be stale. So stale is actually like a law of the universe, right? You're looking something and you're looking at the sun, but you see this 8 minutes past of the sun because of the speed of light constraint. So it is actually the eventual consistency thing. I would say it almost helps you that you do not trust the read side anymore. I mean, because we developers intuitively, when you don't use event sourcing, we trust the source of truth as the database. But once you just have discrepancy, then you lose the trust into the read side. But that's actually a healthy thing, which means actually in the original case where you have a single table, you even can't trust that data anymore. So this is the theoretical part. The next part is I'll just talk about the actors and the concurrency issues. And then I'll just show you a real life, I mean, not real life, but prototype example. How would I implement this thing in F# with actor model? That's just what I'm going to show. So this brings us the other problem. How would we implement? So there are frameworks like Martin, right? Has anyone used Martin? MartinDB, PostgreSQL based. So in Martin, it's basically you open a session, right? You open a session. Let's call it open session. Well, my handwriting is very bad, but so once you have the session using here, you actually load the data, load something, and you get an instance of it, and then you make changes, and then you save something. So Martin can do event sourcing as well, if you look at this documentation, but it still works the way that an entity framework works. In a sense, once you have multiple requests this is your web application. But if you use ORM or entity framework or whatever you like, what Martin and ORMs will do is, this is your DB. Let's say you have a user object. There are 2 web requests coming simultaneously. They will both hydrate the user object, the same user object. They have, let's say, call it ID1, ID1. Although in memory, in your process memory, they will be different objects. And furthermore, your database transaction, even if you have to create a transaction, because of performance reasons, by default, databases work in a mode called read committed. Most databases actually, let's call mode, which means that they are not going to be aware of each other, even from a database point of view, until to the point that you commit the transaction. So what is the problem with this approach? Any comments?
Request could make a decision based on something that's completely wrong now, but they had no way of knowing it.
Let's describe what is wrong.
Sure. Yeah, it's 2 parallel web requests. They're operating on the same. They see the same user object, like the same content. One of them tries to do something that is incompatible with whatever the other one's trying to do, and they don't know about that.
Yeah.
The 2 web requests, like there's a conflict, and they don't know what to do about it, and that's something's got to handle it. That's my idea.
Yeah, that's actually the essence of it. It's a conflict. So this has some data, and this has some data, and then this one changes to this one changes to this. A more realistic example would be, well, you have accounts, right? A1 has $1,000, and A2 has $1,000, and there are 2 transactions come, and they both try to transfer from A1 to A2 $1,000. And let's say we are not allowed to overdraft. What's going to happen is that first it will check, this transaction will check, do we have enough balance, right? And this will also check. And both will yield positive. They say, well, yes, we do have enough balance. And once we have enough balance, then, well, there are multiple ways to do. From this transaction's point of view, the A1's final balance will be 0, and A2's final balance will be 2,000, right? And this will also do the same. So then, in a sense, you will have this kind of outcome in the database. The problem with that, both transactions appear to be worked, which is false. Only one of them worked, actually. Right? So these are your objects, the A1 and A2. So you have a very, very serious problem here. And the solution to this is what you probably know. It's a very common problem. But how do we tackle this problem? One is optimistic concurrency. The other one is the pessimistic concurrency. And they're both awful options. And let's see why. The pessimistic concurrency thing is basically say that, well, most relational databases offer you the facility to lock a row. So I can lock this row, right? And even while selecting it, so this check statement is actually a statement that's actually locking this row. Once a row is locked, and this transaction will also try to read the same row, and this will wait indefinitely. I mean, not indefinitely, but until this transaction commits and releases the lock. And on the surface, this solves the problem, because this will prevent 2 transactions to read this row simultaneously. But let's see the challenges with that. So the first problem is the famous deadlocks. And I have encountered personally a lot when I try to apply. I mean, it looks like you may sound, if you haven't encountered as well. It's probably a corner case. It's not. It in a slightly busy database, deadlocks happen a lot if you choose pessimistic concurrency. The reason is that if two transactions read the database in reverse order, let's say this one is trying to transfer A2 to A1 in the opposite order, then they will block each other's path, and they will wait for each other to resolve. And this is impossible. And as a result, what will happen is that, for example, if you use Oracle, Oracle will choose one of them as victim, and then will kill. And you can see in the database logs is, well, some transaction is chosen as a victim and killed. So that's the solution, and it's an awful solution. And you'll get an exception in your code. It also requires a contention. It's not performant, and it's also very, very database dependent. So I just want to share you a couple of blog posts, just to mention. So this is a good blog post. It's talking about the concept of I hope you can see the acquiring a pessimistic lock. So what you do is, I think this guy's using Java and Hibernate, which is you can think of like an Hibernate kind of thing. And then it uses this log might type pessimistic right, and then this issues whenever you select, you give your intent. I would like to give a for update. This is an Oracle or MySQL specific, and whereas this case is just the for update of what is PostgreSQL. And SQL Server is doing something unusual, different. It just says that, well, I would like to acquire an update lock for and row lock for that. And then what happens is there's a blog posts here, the post and the comments, and this is actually acquiring a lock on the post. And then if you issue an update to this to a comment, apparently for update statements, the all databases will wait. The interesting bit is that we have this kind of relationship between the post and the comment, and you have a foreign key relationship. And somehow databases are smart, or perhaps in a good way or bad way, that they actually propagate your locks to your child table. And update and delete is that. But for insert, the databases behave differently. So, for example, PostgreSQL just allows you to do the insert, but they prevent you to do the update. And what I'm trying to tell you is that this thing becomes very complicated. And here's another article that discusses that. Well, do you want this lock mechanism? Should it propagate to the child row or not? You can control it, etc., etc. Then you have the concept of the parent and child rows, and then think about it. Just you try to acquire, should it propagate this way and that way, and then it's actually it becomes a very complicated problem. There's another option, for example, called serializable transaction. So you can, when you open a transaction, you can say, I would like this transaction to be serializable, which is an awful option because it will say, well, I lock entire table, so no one can work with that. And that's even the subject of the database's interpretation. So it's very. I read this things many times, and I still don't remember what they exactly do, because there are a lot of subtle details. So this is one of the options. So the other option is the optimistic concurrency. Optimistic concurrency is a little bit saner. So people recommend, and if you use things like entity framework, if you look at the documentation, then that's what you see. And so in that case, you have A1 and A2, and you create a version column, something like a timestamp kind of thing, or typically a number or GUID or whatever, I don't know, something that's not going to conflict. But what you do is, whenever you issue an update, you include this version in a where statement where you say that version where is equal to 1. So if someone has changed this number to 2, then entity framework will look at the affected rows. So whenever you execute an update statement in ADO.NET, you can get the affected rows. And the outcome will be 0 if this has changed to 0, because your where condition won't hold, and your update statement will not work. I mean, will not update anything because the version doesn't hold. Of course, by the time two transactions write into the same row, they will block each other. So the first one writes. That's by the nature of the database. And this is, in a sense, how optimistic concurrency works. And if this thing happens, you will get a concurrence exception in entity framework or something, this kind of thing. And what's the problem with that? What do you think? What do you think the drawback with that? Or is it perfect? Are you satisfied that this would work good for you?
It sounds like this would be a worse experience if there's like high volume of writes compared to pessimistic, but that's just a gut feeling. I don't know. It feels like this would be worse in high write volume situations compared to the other one.
Yeah, that's true. Try to build such a system with a stock market application kind of thing, and then
Yeah.
you will fail miserably, actually. Not going to work. So yeah. Another problem is that, well, I don't fully have a full solution to that, but so basically you execute this thing and you retry. Essentially, you get an exception and you retry. If you have some sort of side effects called external services, then it is hard to track if you have made such a call before, right? So essentially, you get an exception here, and what you need to do is you retry. And when you retry, let's say you're calling a web service in between, which is not part of which can't be part of your transaction, right? Let's say you're sending a government office that this transaction happened, then you would be sending this twice. If it's idempotent, then you don't have any problem. But if it is not idempotent, then you might have a duplication. Well, absolutely, there's no solution to this problem, but it actually makes things harder to track. So you may not know that you're retrying or not. So what I suggest based on this, so I talked about the actors. Actors are like objects, and in particular, the Akka.NET actors. So the idea is that they're objects, but they're not bound to a particular memory location, even on a physical machine. They're by default thread safe. So just like you call a function, you call a method of an object, you send a message to an actor, right? Something like that, transfer money. And this is a message. And as I said, an actor is just won't process two messages simultaneously. So you will have the thread safety in the first place. And the essence is that they do event sourcing by default. I mean, as Akka.NET does. So you just get a command here like that, and then you generate some of the events, and those events will be persisted. And then they have, like the Martin, they have the facility to replay those events, which can bring the state to the original state if your system restarts. And then the issue is that your source of truth, well, eventually they're the events, but actually you can also treat the actor as the source of truth, because there's one single global instance in your application. Even if you have multiple distributed processes, that you have 5 physical machines, that's still the case. So at least the Akka.NET guarantees this thing. Akka.NET works with many databases, PostgreSQL, SQL Server, SQLite, Oracle, Cassandra, I don't know, quite a bit actually. Redis, Azure, TableDB, Amazon. So they have it's just so you're actually somewhat persistent agnostic, and it's fairly simple. In particular with F#, I just have to tell how well I just program the serialization part because I like to use tot.json. Yeah, so that's the essence. So in that sense, your actors become the source of truth, and then they can just take the message and then they process it, and then they just take a decision. And whatever message will come here. But if you think about this kind of transaction, kind of actor account, then you will have to, which I'm not going to cover right now. You have a Saga actor, which actually acts like a distributed transit coordinator between these two things. So it will record the state. So is this so you just actually reserve the amount and reserve the amount in a minus positive way, and then it will confirm and confirm, and this will like a state machine, and it will bookkeep with what was the last thing happened. And if the system restarts, it will resume to that point, and then it will redo the actions, and you need to do again idempotency here. The thing is, why we haven't come up with this model earlier? Objects have one big advantage. They're regular objects. They are garbage collected when you're done. So if you have sometimes something like a single source of truth in the memory, and let's think about a case where you are loading hundreds of millions of records, what's going to happen? Eventually, your memory will pile up with these actors. Whereas with if you use like ORM, then you don't have this problem, right? But once your request is done, the garbage collector will remove them, because these actors aren't really objects; they are the more glorified conceptual objects. They tend to live indefinitely. But the solution to this problem is that Akka.NET, if you use an actor framework like Akka.NET, it's something called a passivation. And passivation means, by default, there's a timer. If an actor doesn't receive a message for 2 minutes, then it will gracefully passivate, which means that it will be removed from memory. But it is done in a way that if a message comes again, it will reactivate and pretend as if it is never passivated. It will replay the messages, and that problem is solved actually. So that's the point of it. Any questions, ideas, objections? So I'll just show the actual code for how would you code for this, just otherwise. So I'll just show you a simple application, which is a half finished, actually not even, perhaps only 5% finished, kind of, not even half finished. But the idea is this. So there's a web request comes. The user actually tries to subscribe some stuff or countries. And there's some controller with a draft handler here. What it does is, it first, I will show the code briefly. It first subscribes to read side. Read side, and I'll explain why. Then, this is the first thing. Then issues the command to actors. Then wait until this command is returned. It's a task or async kind of thing. Then, well, actually, yeah. Then it will wait as a fourth step for this subscription to return. And then it will relay the return request. Could you guess why I am first subscribing to the read side? Any guesses?
I'm not sure, but how do you ensure that the read side is up to date with your write? Is there like some kind of marker or something like that, or do you use the like an expected version type or something like that?
Very good question. That's actually the key of it. So what I do is I send a correlation ID. It's a GUID attached to my command. And actually, the first thing I do is I generate a command correlation ID. Then I subscribed based on this correlation ID. Then I issue the command with this correlation ID. And this subscription will yield whenever an event happens with this correlation ID. Does that answer your question?
Sort of, but when you say that it's subscribing to the read model, it subscribes to when a change happens to the read model that has to do with that correlation ID. And what if, like, is this still working the same way when, suppose you have a read model that's based on the state of like 100 different streams. It's not just a one-to-one, you know,
Yes.
one-to-one relationship. Like it'll work in the same way. And is that kind of like a built-in mechanism to Akka.net for like the pub sub, where anytime there's a change on like a single event basis to the read model? And also, is it something that's like actually stored within the read model in some way as like in some kind of metadata, like, hey, here are all the streams that contributed to this thing, and so that's how it's working? Or it relies on like the most sort of up to date, or sorry, not up to date, but it just relies on like, all right, you're subscribing to the read model, and then anything that comes in after you've begun subscribing, if it has to do with that correlation ID, then it'll be notified, so then it knows to return back to the requester.
So this is a manual filter. There isn't a built-in mechanism. There are some helpers. What essentially happens that this command will guarantee to generate some events. Let's say command. This will generate some events. If this has a correlation ID, can generate one or more events with same correlation ID. That's the point of it. Correlation ID is something that propagates from command to event. Okay. So let's say I'm trying to subscribe to something. That's my command. That's a subscribe command. The thing is, I'm going to subscribe here that I would like to be notified whenever a subscription completed event happens with this same correlation ID. Right? That would guarantee me that the read side has actually processed the projection. So what would happen in the read side is that these events will replay, and it will first commit to the projection table, and then publish the event to the subscriptions. So there's the event bus, actually. In a sense, this guarantees, even if you have multiple streams or what, this subscription will as the fourth step you're waiting, you will have the outcome, what you're expecting. So in a sense, the idea is, because it's a web application, I could have just returned at step 3, right? I don't have to wait for the subscription. But what I like is I like the read side also to be complete. I want to deal with the eventual consistency. The reason being is that perhaps, let's say hypothetically, this takes 10 seconds, right? And the user actually wants to see a report kind of thing. And if the user is too fast, click a button or something like that to see the report, and they will see a stale report. And then they will be surprised because they get an OK with the command side, right? And this might generate some counterintuitive behavior. So this is one way to tackle the eventual consistency. I'm not saying it's a fully tackled, but it's somewhat satisfactory. Is this okay?
Yep. Makes sense.
Yeah. So let me show the code. Now let me show the application. So this is the application. Well, if I try to log in, this application is available on my GitHub repo. Just sign in. You can run it, and you can subscribe to some stuff. And if I reload the page, then you can see the subscriptions retained. So that's what it is. Okay. Let's just see how this thing works. I need to reload because apparently I was a bit rushing.
I have some other questions that are like sort of related to the practical matters of making an application in this way, which are, typically in a typical sort of CRUD application, if you want a list of users, you have a users table, you put an index on that, you try and search for a user, you're trying to group by user, you can do it in that way, just on the table directly. In this, when you're creating your user streams, is like something that would be the equivalent of like a searchable index of all users. Is that, for example, just going to be a downstream eventually consistent projection of all of the user created or deleted or whatever it is events?
Could you rephrase?
Basically, suppose you want you want your read model to be like a search of users, right? So
Yeah.
you're typing in a username, it's going to be some kind of like search autocomplete, something like that. One very simple way to do this, or to just, even if you want to say like, hey, show me all users that are XYZ, like, is that always going to be some kind of downstream projection of, you've got all the individual user streams, say, I mean, you could do it that way if you wanted to. So there's like user XYZ, you've got user created as the first stream, and then any other stuff that happens where the boundary, where the the boundary is for that user. So is it the case that all the equivalent of what you might put an index on in a traditional CRUD environment, like all that stuff, you're only ever going to have the equivalent of like eventually consistent queries for that? Is that correct? Like all quote unquote indexes in that?
What you would do is, for that, you would just use your read side tables. Let's say you're searching for users, and then well, there's a stream of users that will come, but your read side query should not be concerned about the stream itself, the events itself. All you have to do is just you create a table, and you would just query it from the read side, and let the projection engine to fill that table, whatever it's doing. That's how it works. Does that answer? So your streams are out of the question here. You're not going to you're not going to try to read from streams. Yeah. So you're only going to hook into the table itself. Because for that, I think the stability is somewhat acceptable, right? You're not going to be interested in, which is impossible. Whatever methodology you use, there is nothing in the world that's called instant. As I said, you see the sun lights 8 minutes past. There's no, because that's not a decision you take. You don't need the absolute data, absolute instant data, because your state is stored in the actors. The actors can decide based on the actual data. Whenever, for example, you want to disable a user, because that decision is isolated inside the actor, that can take the decision, and in a true and accurate way. Let me just go through this, and then I'll just describe one more concept about the why we were separating the read and write, and how should we access these things. So this is a draft application, and there's on the view side, you can just see, I'm not going to talk about the draft part, but there was an index here, I suppose. Oh, no, not here, sorry, the handler, sorry, I missed it. And whenever you hit the subscription, it will go to here. So here you can see, well, I need to zoom this for better clearance, zoom one level. Yeah. So for the first thing is, you can see, whenever I try to subscribe, I create this correlation ID here, just like that. And it generates a GUID, actually, EUID, whatever you call. And once it does it, it will actually, you say that, well, I would like to subscribe, yeah, here. So what it does is it's actually checking the user. That's not much important, but the key is, well, there are two subscribes here. They're actually, one subscribe is a command, which is behind an API, and the other subscription is actually a read side subscription. So don't get confused. It's a little bit misleading. So this line essentially says that, well, I would like to subscribe for an event with the same correlation ID. And perhaps I should have augmented that the event type should be the subscribed, right? Not just the correlation ID. But in this case, I know that there's going to be one event, but I think ideally I should add another condition here, stating that I would like the event to be subscribed. But this is the read side subscription, and this is denoted with this silly letter W here, which is an async of unit, actually. So how this works is just another matter, but let's among friends, let's say this somehow works, and it allows me to subscribe to the read side. So this is the read side subscription. And this line issues a command, and this subscribes as a different through an API, because I like my application to be a CQRS agnostic. I don't, even the view side doesn't know. I don't want to appear to be committing to the CQRS pattern. And it's just an interface which eventually issues a command. And then the subscribe thing will send this correlation ID, and there's some sort of identity, blah, blah, blah. and then it will wait for the command to resume. So this is just, it's actually, if you can see from commands, I return a result, okay, or a result. And that result is just sometimes, it is not a good idea to return actual data, which I will explain briefly, but I like to return the entity version and also set of errors. So this is the second part, is the list of strings which can be representing the errors. And once I get a result, which is okay, which I even don't bother to check. So ideally, you should check if the result is okay. Then I wait for the subscription to happen. And then this just issues the returns. So that's the handling part of the query. So let's look at let's see what happens in the command side here. So this subscribe is actually implemented in something called bear with me. Yeah, I suppose. Let me just a bit shortcut. It will come to here, okay, and then this will bring some code here. So this code, essentially what it does is, I still didn't come to actor part. Before I actually send the command to the actor, it says that, well, I would like to subscribe the command's published events. And in particular, it could be two things. The actor can emit a subscribe command or an already subscribed command. So whichever it happens, I'm okay with that. And I would like to send this command, which is a subscribe command. The command is here, and issue to this actor with this name. So it just sends a command to the actor. Let's see the actor itself, which is actually the most important part. So when you define an actor with Akka.NET, typically I use a framework called ACLink here, which is makes the actors F# friendly. And what I like to do is I like to define the command, what it takes. So in this case, a subscribe or unsubscribe with some sort of details, like the identity and region. And there's a set of events, right, which could be subscribed or some already subscribed or unsubscribed, etc. Also, the third parameter to a typical actor is the state. So this is the in-memory state that, well, what are the subscriptions, and there's the version kind of thing. There's some sort of initiators here, just boilerplate code, not much important. And the actual actor part is that, well, there's a set of boilerplate code, but the important part is we have one apply function. And this is actually doesn't have anything to do with actors. It's just a plain function. And what it does is it gets a state in the event, and then it decides the next state, right? So if I have a subscription, then it just adds this to the subscriptions, and then returns that state. And there's a plain old function. There is nothing magical here. Yeah. And finally, if you have watched the first iteration, which I talked about the mailbox processors, this is a Akka.NET actor. You use this actor computation expression, and what it does is it just processes the messages in a way such as let's say we match the commands. The command comes here. If the command is subscribe, well, we say that do we already have a subscription? If so, then the decision is the already subscribed event. Otherwise, the decision is a subscribed event. Notice in this case that the V is here unchanged, and in this case the V is +1, which means that I increment the version by 1, because this implies a state change, and this implies no state change. And this version is just more tracking purposes, not very important here. Something that I'm going to cover, that perhaps this event might start a saga, and this line is just checking it. And then what does it do is the important part is that it actually says that, well, I would like to persist this event after the saga check. And once that outcome has come, in addition, I might persist 2 events. There's something called remind before set. So I might either decide to persist 2 events or 1 event, but that event is persisted from here. So once you return the persist effect, this is an effect actually which wraps the event. What will happen next is that the event will be persisted, and it will lend to the apply function somehow, magically. And that actually is the actor side. So in a sense, you first go to create a command and create a set of events. And then you define your apply function outside of the actor. And then you have a loop here, which takes the command. You take a decision, what is the generated event, and then you persist the event by using, which eventually you wrap this thing, you wrap your event to a persist. This is baked into the Akka.NET by Acklink, sorry, effect. This is an effect. And then you return that effect. And then once you return that effect, Acklink will persist that thing. So that's the command side. Let's look at the read side. Yeah, you have to see the query in the projection. So on the read side, what we do is Akka.NET and Acklink offers us a facility. It's called read journal. We can give an initial offset, the starting point, and then it will actually lists in all the events, and it's like a reactive extensions kind of thing. You get a source that you can subscribe. This part is the, remember that I mentioned about the event subscription, which I'll skip it for the time being. And what you do is, for each event, you send these events to something called a custom function of mine called event handle wrapper, which will eventually yield that event to here. So let's say we have the subscription event here. Subscribe event came here. So it's just the original event that we described inside the actor. And what it does is I use a SQL provider. I create a row, and basically I'm just updating a row. And so then whatever you do, you can just query this row. So that's the basic cycle. It's a very short, fast, quick tour, I know, but it is not possible to explain this in a very detailed way, not under 2 to 3 days. But I just want to give you a glimpse of it. Any questions? Too complicated? So this is a pattern I apply. You can come up with your own pattern. And before closing up, I just want to explain one more topic. The conceptual topic. My objective with this presentation is that it is just a little bit, give you a little bit more concepts. A practical implementation is actually tedious because there is no built-in framework, and I haven't made frameworkized this yet. I'm not sure if I ever will. The first thing is, as a closing, when should you apply a CQRS? It's if you have an application. I like there's a concept called micro frontends, and there's a, let's say you have UI portions, and I like these micro frontend parts backed by some sort of backends. So you don't have to commit your entire architecture into CQRS, but perhaps a reasonable part. So you can make a portion of your, I like this vertical slices, a portion of your application as a CQRS, and another part as a CRUD. But that's a very sane approach. So you can split your application architecture in vertical places and then vertical pieces, and then you can apply CQRS on a portion of it, and then the other ones you can just go with the CRUD if you like. It's not as complicated, and to be fair, it's almost this became my default application architecture for even if it's a small application. I still go for this. Another important bit I like to show you is that you have these actors, right, which I talked about. So there's an actor here. So you will have a position at time if you go with this actor to temptation to call get state, and that's a very wrong thing. So let's say this actor wants to know what's going inside, right? It can issue a message called get state, and then this can return its state to here. So this is actor 1, actor B. But I claim that this is not something that you should do. Why do you think so?
That's mixing the CQS separation that we've set up so far, right?
True, but I mean, your answer is it's perfectly correct, but it's slightly dogmatic. So I don't want dogmatic. So there's also this question is aligned with the other question. There's a database, read side database. And we say that we should not also access to the read side from the actors, because the command side should not access the read side. But obviously, this is mixing up concerns. I mean, it's not super dogmatic, but there's something I'm looking for a little more. What could it be? We shouldn't do this either. But you will be tempted. I mean, I became tempted to do this, because you need some data, right? While trying to decide, you will want some data, and you will be, well, I should ask this actor what's going on, and I should just go to the read side and to take a decision. But it's almost always a wrong decision, not because CQRS says, well, you should not mix. Well, that's true, you should not mix. But the reason is by the time if you make your decision by getting this data, that thing can be stale. So you get there's a data here, right? By the time you get this data can be stale. And you're not allowed to take decisions based on stale data. And same goes here. So if you're trying to read if you're going to take a decision from the read side, and you're trying to read it, I mean, well, in my earlier times, I was thinking, well, I should not read the read side, but then I was tempted. Who cares, right? It's one time only. I will read it. But then you came to the realization that whatever you read from here or you read here from here, it can always be stale. And if you take that decision, and then you're taking a decision based on stale data, and that's not acceptable. If this is acceptable, then that's fine. You can do it. So if you can access, that's the primary reason, actually, not to because that read side or whatever the other actor is going to be stale. Because by the time you get this data, maybe there's a message coming here and it's changing that data, and then you take the decision that's not correct. So this is something I just want to clarify. Yeah, I guess that's all. The repo is available at my whole history is gone.
I have one final question, which is, I know that you've sort of you've followed this pattern. I've seen it followed like in the pizza workshop repo, and then in this alarms.global repo. Is this something you've ever thought of like cleaning up and making a little bit more framework style, since it's a sort of
so that's a very good question, and perhaps I should. Perhaps it's the reason is I'm lazy, but I like this to be a pattern rather than a framework. So I'm very frustrated with frameworks. In that sense, what happens is that whenever I start a new project, right, what I do is I basically copy paste these three files, and it's constantly evolving, actually. So that's my framework, actually. But yeah, maybe I will do. It still needs a bit polishing. I'm still ironing out some of the issues, but yeah, you may be right. I don't know. But at this point, my stance is a little bit. This should be a pattern, not a framework. Yeah, maybe how it is. So do I use this? So I have maybe you know me. Some guys, I have an application called Beandrake. It's a very simple application, but well, so it's a 3D bean packer. Where do I use this pattern? It's a production thing. It's just actually people pay for it, although I can't say it's making any profit. And there's a subscription, but there's also credit base. So if you make calculations, it reduces. Well, if I just go with the sign of the credit-based account, then you can see that it reduces the credits, actually, the calculation. So this guy has 22 calculations, and then if I just use this, yeah, well, so you can see it reduced to 21. So by applying this pattern, I'm pretty sure no one can cheat, because you can send multiple concurrent requests to execute more than one calculation. So this data, this credit is actually stays inside an actor, the amount of it, and it's guaranteed to be concurrent. And this has been alive for 2 years almost, and it's using SQLite database, just like that. So I just want to show you a slightly real life example. Any other questions? I don't have anything else to share. Otherwise, I'll share this recording, and you can find me on Twitter, I suppose, if you have any questions. I plan to make a 4 to 5 days workshop, going through a little more comprehensive, but probably around summertime. So yeah, these times are a bit busy. That's all from me. Thank you for listening.
Great. Thank you. Appreciate the time.
Yeah.
Really
Yeah.
Thank
appreciate it.
you.
Thank you.
Have a good one. Bye.
Thanks.